For our next trick, we're going to find the Maclaurin series for f of x equals x squared e to the x. Now, you've seen already that there's this formula for Maclaurin series that goes like this: m of x equals the sum from n equals 0 to infinity of fn of 0 over n factorial x to the n. And you might be tempted to use that, but the fact is that if you try to find this derivative through multiple applications of the product rule, it's going to be really, really messy. Because if you think about it, you're going to have to start with f prime of x equals x squared e to the x plus 2x e to the x, which is x squared plus 2x e to the x. Then you're going to have to do f double prime of x equals, that's going to be x squared plus 2x e to the x plus 2x plus 2 e to the x, and you'll have to combine all of those. It's just going to be a real mess. And the point is, you don't even need to do that. Let me show you why. I'm going to erase this. I didn't even write it neat because I knew I wasn't going to keep it there. It's just not the right way to do it. And this is, what you want to do is recognize that e to the x is equal to 1 plus x squared over 2 plus x2 factorial. Let's say x cubed over 3 factorial plus dot dot dot. So, or I can just write it in its sigma form. And I realize that you're looking at me do this and you're saying, oh, well, of course he's a math professor, he can do that. But by the time you get to the quiz, you'll be able to do it too because it's kind of required. So anyway, if that's the case, then that means that x squared e to the x must equal x squared times 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot dot dot. Or I can just write this as x squared times x to the n over n factorial. So let's see. So what does that actually equal? That's going to equal the sum from n equals 0 to infinity of x to the n plus 2 over n factorial. It might be a little bit more convenient to be able to have an x to the n term visible. So what I'm going to do instead is I'm going to rewrite this as the sum from n equals 2 to infinity of x to the n over n minus 2 factorial. If you want to convince yourself this works, just look at what the first term is going to come out to be. Here I have n equals 0 and I get x to the 0 plus 2, which is x squared over 0 factorial. In this series I start at 2, so again I get x squared over 2 minus 2 factorial, which is 0 factorial. So they do match. All I've done is I've shifted the index. By 2, which means that I have to adjust all the uses of n accordingly. So that's the series. This is the Maclaurin series for x squared e to the x. And as you see, I didn't need to find a whole bunch of derivatives to do it. I just took x squared and multiplied it by the series for e to the x. Now I'm going to add in a little problem here. Let's say find f5 of 0 using these facts. Now, how can we really do that? How does it make sense to say find x5 of 0? That's where this formula comes into play, and I'm going to show you how. Let's write out the first couple of terms of the series. First couple of terms of x squared e to the x is x squared plus x cubed plus x to the 4th over 2 factorial plus x to the 5th over 3 factorial plus dot dot dot. Okay, now recall that a Maclaurin series, let's do this, has to look like this. It has to look like f of 0 plus f prime of 0x plus f double prime of 0 over 2 factorial plus f triple prime of 0 over 3 that's going to be x squared. This is going to have an x cubed after it. This is going to be the fourth derivative at 0 over 4 factorial times x to the 4th plus the fifth derivative at 0 over 5 factorial x to the 5th, and we keep going. The point is, whatever term has an x to the 5th in it, its coefficient has to look like this in order for it to be a Maclaurin series. So let's focus on this term. This is 1 over 3 factorial x to the 5th. Since this is a Maclaurin series, that means that this term has to be equal to that. If it weren't equal to this, it wouldn't meet the formula for Maclaurin series and therefore wouldn't be a Maclaurin series. Now, I know a lot of you are looking at this and saying, wait a minute, where's this? How can it be? How can I have a 5 factorial in it? It has a 3 factorial in it. Well, the f5 of 0 is going to account for that, and we'll be able to solve for it. It doesn't matter what this looks like. What I know is that the coefficient of x to the fifth in a Maclaurin series has to be equal to this expression. So what I can do is I can simply equate the two expressions. Say f5 of 0 over 5 factorial is equal to 1 over 3 factorial. So I'm going to multiply both sides of this equation by 5 factorial, giving me f5 of 0 is equal to 5 factorial over 3 factorial. And I can even simplify that. That's just going to be 5 times 4 times 3 factorial over 3 factorial. Those cancel, giving me 5 times 4, and the answer is 20. So it wasn't necessary to differentiate this whole series 5 times. We were able to simply read the answer off of the coefficient of x to the fifth, simply by equating what we know has to be the coefficient of x to the fifth with the coefficient that we actually see in the series. We'll do another problem like that a little bit later.